we're really on tidy up phase here. Our job is to finish 6.3, which is what you need for the coming online test 4, and your homework finishes on 6.3. Lots of things to memorize, of course. These are the 2 main topics that we're going to be, we still haven't completed, although the top one is totally revision, and the second one is totally new. And before we return to this, next week is a normal week. Next week is week 5. 5 days, usual. Test at the end of it, everything as usual. But the following Monday, that's a week on Monday, we're going to have our midterm. So try in this coming week to see if you can get a couple of more hours somewhere in your schedule to get ready for your midterm, right? Because, you know, what we did away back in week 1 isn't, you know, that's a lot of stuff has happened since week 1 to the end of week 5. And your midterm is quite different in a lot of ways, because your midterm is going to be all done in class, and it's going to be in a PDF format. So you've got to be careful that you're ready. You can certainly use any written notes you've got, but it won't be the same as online. It'll be much harder, and it will be worth a lot more points. So make sure you're as prepared as you can be.
Is that on the 9th?
I don't want to say that until I've checked the calendar. Come on, why can't I hit the calendar button? I can't hit the calendar. Okay, there it goes. Tomorrow is the 30th. Monday is the 2nd. Yes, it is the 9th.
Is it going to be at 10?
It's on a 2-hour period. I don't know right now, but I'll tell you. Well, you can go and look in the syllabus and find out, but I can't remember right now. But it's going to take 2 hours. So I'm betting money it's going to be 9 till 11, right? Or 10 till 12 if that works for you. But it's going to be a 2-hour window, whichever window suits you best.
So we can choose which window suits us best, because I work at 11:45.
Yeah.
Okay. Cool.
Yeah. We'll talk more about it next week when it's closer to the time. That way I can get more prepared and make sure I tell you everything correctly. So let's get started. The 2 main topics are, we're going to look at the unit circle, which is a big bunch of questions, and it's totally revision. There's nothing different in it. But haven't we done, you know, all sine, tan, cos stuff, and that was revision as well, right? So this kind of section is a big overlap. And then we're going to spend a lot more time on these darn things. These are messy, but there are only 3 of them, thank goodness. And I think just to start things off, let's do an overlap. Suppose I tell you that the sine of theta is -7/11, and that theta is in the 4th quadrant. So we're going to do one last one of these, find the other 5, right? Find the other 5 trig ratios. So if I do the all sine, tan, cos thing, 1st, 2nd, 3rd, and 4th quadrants, we kind of have to figure out, well, we don't actually have to figure out, now that I've figured that one out. It is the 4th quadrant. For a moment, I thought I told you something like cosine theta is positive, but I hadn't. So that's the easiest one, isn't it? Because you know which quadrant it's in. But don't they also tell you things like cosine of theta is positive, right? In which case it would have been the 4th quadrant. So you build a right angle triangle. I like to put my triangle with that orientation. No reason why I should, I just like that one. Then I can name the 3 sides, which I think we should be really good at doing now. We've had plenty of practice at doing those. And then you go up here and you find the sine is opposite over hypotenuse. And that means you can put a 7 there and an 11 there. And then we get the adjacent by using Pythagoras. 7 squared and 11 squared. And then if you subtract 49 from both sides, oh, that's 29, you get 71. No, you don't. 72. And you get the square root of 72. And that's 4 times something, isn't it? It's 8, and then 4 times.
36 times 2.
A bit louder, please.
36 times 2.
You got it. So we can simplify this down as a 6 root 2, which is fine. So now, once you've got that set up, can't you actually find all of them? Let's just pick a couple. Let's choose, say, the cosine of theta, and let's do cosecant of theta. Right, so if I want the cosine, it's going to be the adjacent of the hypotenuse, and the adjacent is 6 root 2, and the hypotenuse is 11. And then I say, okay, you're in the 4th quadrant, so that's positive. Then I find the cosecant, and the cosecant is the opposite of the hypotenuse. And the cosecant then is, try that again, it's the hypotenuse of the opposite. So that's going to be 11 over 7. And doesn't the cosecant behave the same way the sine does? So it's negative. And if I'd thought about it, couldn't I just turn that guy upside down and got the answer a lot quicker? Because a cosecant is just one of the reciprocal of a sine. That's kind of yesterday, wasn't it? That's kind of the last thing we did there. So let's get a couple of these guys just out of the way. And these are questions 1 to 16. And when you look at them, you will say, we know how to do them. And I'm hoping that you will agree with me. They want you to find things like the cosine of 150. And then they might say the cosine of negative 30. And then tangent 135. And let's say a cotangent of negative 120, right? So there's a good mix and match. All of these fellas, all of these guys will come from the unit circle. So here's my unit circle. And we just have to remember X or Y coordinate, right? What combination do you get? Now, when you're doing a cosine, is it the X coordinate of the point or the Y coordinate? Which one is the cosine again?
X coordinate.
So then you go looking for 150 and you'd write down the X coordinate. Now, if you want a cosine of negative 30 degrees, yes, it is the X coordinate, but in this case, don't we have to find out where another place that's the same place as negative 30 degrees? And I think I did something like this last time, but isn't the answer 330? Great. 30 degrees that way, or just add 360 if you're stuck. Right? And in this case then, the X coordinate happens to be root 3 upon 2. Now, if you want to do a tangent, you have a little bit of more work. It's the Y coordinate divided by the X coordinate. Okay, that's the tangent then. I'll find 135, which is over here, and the Y coordinate divided by the X coordinate. A little algebra trick here. If two fractions have the same common denominator, do you know that you can just, like, they cancel out? Now, if you want to do a cotangent, there's a little bit more work in this one. The first thing I'm going to do is find out which angle in the unit circle is the same place as -120. Now you could go this way and go back 120, which is totally fine, but couldn't you also just add 360? In both situations, don't you end up at 240? Now, if the tangent is the y coordinate divided by the x coordinate, which it is, won't the cotangent be the x coordinate divided by the y coordinate? Does that make sense? So I'll now find 240 degrees, which I had a moment ago and then I lost it here. And I'm going to take the x coordinate, which is this guy, and I'm going to divide it by the y coordinate, is this guy. Essentially cancel out the 2's, and both of these are negative, so we get that. And if you want to make it a little bit prettier, positive √3/3. So are you comfortable as long as it's an angle in the unit circle, or you can find a place in the unit circle that's the same as the one you started with? You should be able to find any one of the 6 trig ratios, right? Good, can we stick a fork in that one and call it done? Right, it's done. Now, the horrible one. No better way of describing it. These are messy. Here are 3 more identities. They are not used a lot. In fact, they're pretty much only used for these 3 questions, but we need to know them for these 3 questions. These identities here are very, very useful. They get used a lot in a lot of places. I'm doing a Calc 1 class today and we were talking about differentiating trig functions, and we were using all sorts of things from here to do that. This, not so common. So what does it say? It says that you can write down a cosine in terms of sine. So the cosine of an angle is the square root of 1 take away sine squared, or the cosine of an angle is negative that guy. And the reason why some are positive and some of these formulas are negative is that it depends on which quadrant theta is in. You know, in some quadrants, isn't the cosine positive? And it's positive in the 1st and 4th quadrants. So if you know the angle theta is in the 1st or the 4th quadrant, use that guy. If you know the angle is in the 2nd or 3rd quadrant, the cosine is going to be negative, use that guy. And then if you switch it around, you can write down the sine of theta in terms of a cosine. So the sine of theta is this ugly square root when theta is in the 1st and 2nd quadrant because it's positive. And I forgot to put my guy in. It's negative, this guy, when theta is in the 3rd and 4th quadrants. So this is just information that we are going to be using. And the question, I'll actually write down the way it's phrased because it's very cryptic. They could have done a better job of telling you what they wanted you to do. But it says, write the first trig. So this is what it looks like. Write the first trig function in terms of the second. For theta in the given quadrant. And the first function is cotangent of theta. Then they write down sine of theta. And then they write down theta is in the 2nd quadrant. So what they're asking you to do is to rewrite cotangent of theta using nothing but sines. And they're telling you that theta will be in the 2nd quadrant, right? So they want you to start with cotangent of theta, and rewrite it so that it only has sines in it, and use the fact that theta is in the second quadrant. So we're going to take this guy, and I'm going to go over here, and I'm going to find an expression that has a cotangent in. And if you look down here, can you see the cotangent is 1 over tan? See that guy? So it's going to start life as 1 over the tangent. But the tangent is sine over cosine. So it's 1 over that guy. We call that a reciprocal. So what we really have is that guy. So I use these identities to come up with the result that cotangent of theta is the cosine over the sine. Does that make sense if you cut the corners? If tangent is sine over cosine, won't cotangent be the reverse of that, right? Cosine over sine. That's essentially what that is. Now, that would normally be quite a nice thing to do, but we are being asked to turn this into sines. Well, I know what sine theta is. It's sine theta. I want sine thetas. I have a cosine, which I'm now going to use one of these two guys on. Now, since theta is in the second quadrant, am I going to turn cosine into this guy or replace the cosine with that second one? Which one is relevant when theta is in the second quadrant?
The second equation.
And so that means you stick in a negative, a square root of 1, take away sine squared theta. Are we good? So
Just tell also that it would be negative based on the fact that it's cotangent and it's in the second quadrant.
you could indeed,
Okay.
yes. In a way, isn't that a nice backup that you know you've done it right? I thought it was going to be negative, and both ways tell me it's negative. Everything looks good. Now I'm going to try something here, if you bear with me just for a few moments. And that is how to type this into WebAssign. And it just came to me that it might not, oops, I want to do it as a student. So let me hit another button. Okay. Am I ready? Come on. There we go. I forgot to tell you what question this is, but it doesn't matter. Oh, of course it's cotangent, cotangent, cotangent. Oh. They keep changing the darn questions on this. Okay, that's finished. We're going to do another one, and then I'm going to try and see if we can make it happen on the thing. You already have experienced that. You know that when you go in, WebAssign randomizes the questions. Well, the question I wrote down was the one I have here, but when I got back into, setting up, I changed the question on me. So that's basically my complaint. So this is question 17. And we're being asked to take secant of theta and rewrite it in terms of sine theta. And theta is in the third quadrant. Now, I know that I have to use sines or cosines, right? In this case, I need to do sines. And I have to find a different way of writing secant. And so the one I'm going to use is this one here. Do you see it says 1 over cosine? Secant theta, 1 over cosine. And then I use one of these two guys. because the question wants the answer to be in sines, not cosines, although I needed this before I could get that. So I need to figure out what the cosine is. Is it the top one or is it the bottom? Well, since it's in the third quadrant, it's the bottom one. And so that tells me the answer is negative. I know the negative is here, but if the answer is negative, don't we kind of stick it in the top or at least in the middle? So I've just picked it and moved it a little bit. And that is the answer, right? We're finished. So now I'm going.
Oh, sorry.
Yes, question?
Do we have to get the square root out of the bottom?
No.
Okay.
If you're thinking that is 1 minus sine theta, it's not. You can't simplify square roots of adds and subtracts. You can only simplify square roots have multiplications going on.
Oh.
So that's actually, you couldn't do anything useful to that. So let's go in and see if I can figure out how to type that in. Right, it's this guy here. And so it's going to be -1, which is the easy bit. And then I just hit the division symbol, which is fine. I should be able to get the square root. That one I'm happy about. This is the bit I'm having trouble with. So one takeaway, it should say sine square theta, right? Now, if things were nice, and I don't think it's going to do this, but if it does, I'm going to be really happy. Right. If things were nice, that's how you would type in sine square theta, right? I can tell looking at that, that isn't sine square theta. I know what it is, but it ain't sine. So I have to figure out how to do that. And the only way I can think of doing it is putting a bracket around it, doing sine. Now, if you're wondering where theta is, you can hit the Greek symbols and then just pick it. Or you can just type in theta. And then square it. So sine square theta is actually sine theta in brackets being squared. So fingers crossed.
It also
Mhm.
it also works if you just go back in the cursor to sine and then uproot 2 there.
Okay, hold that thought. I like what you just said. I want to see if it takes this one. Okay, if all else fails, that will work. Now, let's see if we can make what you said did. So basically, I'll just rub out all this other stuff, right? Yeah. And okay. Yeah. So if I pitch up right, you move the cursor to what here? And then you just put in a square. Okay, let's go for it. Oh, you're just too cool for high school. Would you look at that? So you type in sine theta first, and then you go back. So between the sine and the theta, you do a little up button square. Cool. I now know how to make it do that. That is cool. Next, let's do one more of those guys. What have I not done? Well, they only have 3, but of course they continually move them around, don't they? I think I did that one. Yeah, I did. I think I did that one. Oh, okay. My version of question 19, it may not be yours, but this is mine, is take the cosine of theta and write it down in terms of sine theta, and theta is in the second quadrant. Well, I don't have too much to do here because I'm really good to go, aren't I? Isn't it this guy? So the cosine of theta is either this one or that one, and it's in the second quadrant. So it's this one. And we are finished. Now, I'm going to try and sell this one. I don't think I'm going to sell it very well, but I'll try. If I told you that the sine of theta was negative a third, and I told you that theta was in the third, we'll have to do a second quadrant, right? Suppose I told you that the sine of theta was a third, and theta is in the second quadrant. Then if I use this formula, I can tell you that the cosine of theta is negative the square root of 1 take away a third squared. And that is negative 1 take away a ninth, which is negative the square root of 8 ninths, which is that guy, which eventually gets you that guy. So if I know what the sine of theta is, and I know which quadrant it is, can't I also get the cosine? And I don't need to build any right angle triangles, and I don't need to do any SOHCAHTOA. All I do is have a formula, replace the sine by that. Now that I know the sine and the cosine, okay, so I know the sine is this, and I know the cosine is that, I can also get the tan of theta. How would I find the tangent of theta when I know these two guys?
Candidate's name is sine over cosine.
In this case, it's 1/3 over negative 2 root 2/3. Can't we do that little tricky cancelling the threes? And we got that answer. It's kind of nice. Now that I know sine, cosine, and tangent, can't I also now get cosecant, which is 3, secant of theta, which is 3 over that guy, and cotangent of theta, which is, turn that guy upside down. So isn't this an alternate way to find all 6 trig ratios without building a right angle triangle and doing all the SOHCAHTOA Pythagoras stuff? Agreed? Maybe it's because I'm a visual learner. I don't like doing it that way because I'm careless, and don't I lose pluses and minuses? Not that I don't in other ways. And maybe I've already done it once. Did I do it once? Question?
I take it back.
Take it back, okay. But it is an alternate method. You agree this would be a method that you don't need to do any geometry. And for some people, they like that. So if the question we did at the start, the first question we did today, or some of the other questions from yesterday, couldn't you do all of them using this technique and not draw a picture? And I know maybe some of you would do it that way. I don't, you know, everyone's brain is different. So let's finish with a joke.